Hello, everyone. Welcome to another Thomas Expert series. Thank you for joining us today. We're going to get started in just a moment. In the meantime, double check your microphones. Make sure you guys are all muted. This expert series is going to be on demand within 24 hours or so. So please let your colleagues know how much you enjoyed the presentation today. Direct them to the on demand tab or have them sign up for future talks. To get everyone a little familiar with the chat, I'm going to do a little bit different today for everyone else that's been in here a couple times. What's the weather like today, and where are you at? I'm in New Jersey, and it is a beautiful and sunny day. Where are you at, Michelle?
Beaufort, Georgia, 69 degrees.
Wow, so we got some nice weather. Couple Jersey and beautiful, Philly, beautiful. Sunny in San Diego. Sounds like it's a nice sunny day everywhere. Anyone got any rain? Not seeing any rain today, so that's good. Oh, Oscar, it's rainy and cloudy in Florida. That's not good.
Actually,
Everyone else
they're having flooding down on the East Coast, down south by near Miami, I think.
Oh, all right. Well, this time I'll go ahead and turn it over to Michelle here to give us a review of the methods and equipment required for performing microbial testing of liquids.
Thank you. Good afternoon, everybody. Thanks for this opportunity to speak. Now you know that I'm real. I'm going to stop my video just so that just in case it interferes with the bandwidth. So today, yes, we'll be talking about filtering our fluids, liquids, beverages, etc., and why you should want to impress upon our customers Millipore Sigma. So where are our products used? What options are offered, and how have we improved the products to make them easier and better for our customers? So typically, when you are looking at these products and encounter them in our customers, they're going to be in the quality control labs. They're going to be filtering a product. They're going to transfer that membrane to a media. They're going to incubate it, and then they're going to look for results. So they're going to look to see what kind of contaminations levels there are, whether or not that complies with the regulatory requirements. Whether it's pharmaceutical, beverages, university, or public water, they all have different guidances, etc. So we want to make sure that we're, somewhat familiar with what they're trying to do and accomplish. And what we know is that for when it comes to beverages, basically we're looking at the Code of Federal Regulations, Part 165, and that tells us what needs to happen in the way of the most amount of contamination, what's acceptable and what's not. They're also going to check for, let's say, your soft drink facilities. They're going to check the mixing tanks in the process, and they're going to check the filling heads after they've done their cleaning. A lot of them are going to clean the production line, and then they're going to flush it out with water, and then they're going to take samples of that water, run that through a membrane or filter. Basically, that's interchangeable. They're going to run that through the membrane, transfer that over to the auger plate, and then look to see that the cleaning process has been working correctly. In the pharmaceutical industry, they're going to be trying to follow the United States Pharmacopoeia chapters 61 and 62, which discuss bioburden testing, and that talks about in-process materials as well as raw materials, of what's acceptable, what's not. And you're going to be looking for organisms that are, of particular interest. As we move along, we look at our drinking water, and in 1948, the Clean Water Act was enabled, which makes us all very happy, and why we feel comfortable and confident to be able to drink from the tap the way we do. So they're going to be following the analytical methods from the Code of Federal Regulations, Chapter 40, Part 136. And then in that chapter, they're going to be talking about what is acceptable, what are the levels that are for the treatment plans. With regards to the university, so universities, they will perform a lot of testing, but they really don't have any guidelines. They are, they're developing ideas or they're developing products. So the university itself won't have guidelines per se, but they are going to be trying to maintain the guidelines for which they're selling at or trying to promote to. So if they're trying to develop a drug, then they're going to try and remain in compliance with the FDA, with the United States Pharmacopoeia. If they are looking to do let's say a beverage of some sort for a sports beverage, or they're trying to develop something that way, or food, then they're going to be looking at those guidelines. So they will sometimes do the minimum amount of testing that's required. Sometimes they'll do 1 mil, sometimes they'll do 100. All looks to how they want to do it. And not to mention, they also use it for HPLC, high performance liquid chromatography. And so they're always looking for good quality water, which helps them do their analytics. Now, if they're only doing a 1 mil size, there are options out there that we provide. And I just thought I'd throw these in very quickly. And these are just swab test kits. And it allows them to pour their sample into the little vessel. And when they dip the paddle, whether it's the yellow, the red, or the blue one, there's a sponge behind that membrane, which will draw only 1 mil, and that's QC to do that. So it's reproducible, and there's a dehydrated media in that pad, which then means they can very, very easily take a 1 mil sample. Now, this is fine when they're just doing monitoring, but when they're trying to remain in compliance with regulatory agencies, they typically recommend 100 mil. But this is a great way of overviewing what's out there for the way of their water. Now, what are they going to pick, right? Are they going to use reusable funnels? Are they going to look to a disposable funnel? Or are they going to look for something that's pre-disposable, pre-assembled and disposable? So as you can imagine, reusable means that there's more manipulations, and the more you get to pre-assembled, you don't have as many manipulations, and therefore it costs a little bit more. So when we're looking at the least expensive method, you're typically working with a funnel, and then you're going to assemble it by putting a membrane in between the base and the funnel top, and then you're going to clamp it down. You're going to pour your sample through the funnel, run it through the manifold, which I'll show you in just a minute, and then you're going to transfer that membrane over onto an auger. So you can see that there's a lot of manipulations going on here, a lot of chances for contamination, if you want to call them user error, or just cross-contamination with the environment, etc. But as you can imagine, anytime you do this, it's the least expensive. So if you've got somebody that's on a really low budget and they're trying to work, they're very likely doing something like this. They're all going to be using manifolds, whether a 3-place or a 6-place. There's even 1-place manifold out there that can help instead of having a glass reservoir. So this helps remove the glass from the workbench. People have used glass for a long time, but as we know, glass is breakable, and a 2-liter filtration flask is not cheap, and they typically will chip and break, which increases the chance for contamination and also injury. So there's more and more migration towards manifolds, but there still are companies out there that are using the filtering flasks that are out of glass, and some of them are not aware that we have just single head units out there. So if you ever go into a facility and you see just a single filtering flask, then you may have an opportunity presenting to yourself. Again, now we have a reusable format, and what happens here is it has a little bit You can see here the manipulations that go on where you have to transfer it all over. But while the customers say this is the least expensive option, how much are the chemicals that it takes to clean it up? How much does it cost to run an autoclave? What is the environmental impact of the chemicals that they're using? What is the cost if there is a contamination? So let's say their cleaning process isn't as sound as they want it to be, and there's a contamination. Now they don't know if the contamination is due to um, um, their product, or is it because their cleaning process wasn't good enough? And then what's the cost to assemble all of that and put it together? These are some of the things that when you're looking at the cost of it, don't get considered, but it helps with your discussion when you're trying to move them up towards a disposable product. So here we have a disposable product that works with a filtering cup, and you transfer the membrane onto a manifold, so you're not using the glassware. The cups are pre-sterilized, etc. So these are options that are out there for the customers too, right? So again, now we're reducing the risks. It's a lot less expensive than a full onboard, but it's still more expensive than what they were currently doing if they're assembling all of the products together. Now, obviously, the easiest one is if I can take the funnels out, take the forceps out, take assembling with the membranes out, transferring that membrane. If I can remove all of that, that removes all the risk to the customer, and that's where we want to go to pre-assembled devices, right? So they're disposable, they're pre-sterilized. The cost per test will seem more expensive, but as I mentioned, you saw those different variables that are out there. Is it really more expensive? It will appear so because you're cutting a PO for these products, but when you take into account everything else, maybe it's not more expensive. What's the labor? If you go into a lab and you see that people are moving around like crazy and they're always talking about how they're busy and they're using they're using reusable products, ask them how much an extra hour a day would be of value to them. What could they do with that? And what happens is the pre-assembled products allow them to work on the activities that are a little more critical instead of just trying to assemble the product. And there's no sterilization involved, no autoclaving. So again, you're saving a lot of time and a lot of money that way. One of the questions that we do get is whether there is a recycling program. And unfortunately, there is no national program for recycling, and each state does it differently. And one of the drawbacks is that if they were simply using water, I guess that would be easier. But some companies are using it for their product, in which case we don't know what it is, how to dispose of it, etc. So each state has its own recycling program. We have full data sheets on what these are comprised of so that they would know how to dispose of them properly. But we do not have a recycling program currently. It is something that comes up pretty much every year in discussion, especially because we're trying to remain green and throw less waste. So every one of them is going to use media. Every one of these accounts is going to transfer that membrane onto an auger plate, or they're going to use a Petri dish that has a pad in it and then use 2 millampules, which you see in the middle here, and then they're just going to squirt that onto the 2 mil pad. That will allow, and then you place the media on, the membrane on it. One of the advantages for that is that it takes less space in the refrigerator, and that is sometimes very appealing for people that have, obviously little real estate in their labs. I'm sure you've been into facilities where the lab is quite confined and there's not a lot of space. So the smaller the refrigerator for storing the media, the better. So now that we kind of see how they're using it and what they're using it for, why would you want to direct them towards Millipore Sigma? What is it that makes us better? We've got funnels. They have larger surface areas, so they're faster filtration. Our pumps are quieter. and there's no water trap needed for that. And I'll get into that a little more specific. The manifolds are quite nice, and we have a membrane dispenser. So when we look at how you walk into a lab and you see what they're using, some of it looks kind of industrial. And while it does work, it also presents opportunities for organisms to latch onto. And when we're doing work for microbiology, the last thing we want to do is continually provide opportunities for the organisms to find a little nesting, place and then contaminate your samples. So instead of having a pump that looks like a spray pump, a paint pump in an auto garage, we now have a nice streamlined pump with a nice streamlined manifold. The dispensers are clean lines, easy to take care of, and the funnels are clear plastic, easy to use, easy to take apart. And you can see they're also designed for a good contact with the membrane to the agar plate, to the media plate. The membrane has a little bow to it, which allows for you to remove the chance of poor contact with the media. And I'll touch on that in just a moment also. So when we talk about the membranes in the dispenser, it is a very fast dispenser. You can see right in the middle where the black dot is, that's an actual sensor. So all the lab tech has to do is wave their hand in front of it, and the membrane will come spitting out like you see there. You can see what the number is. Each box itself has 150, so they know whether or not they're going to have enough membranes to last the day, or whether they're going to have to get a box as the day goes on to replace and reload. It's very simple. Also, it's just you thread it in, close it down, press OK, and off you run. So this makes it a whole lot easier because we're not manipulating the membranes if you're doing the assembly process. When it comes to the manifold, we worked really hard to change the way manifolds are out there. We made them clean lines. You can see the way they look. They're very few threads to these. Everything is welded. And again, the reason we do that is because anywhere there's a thread, that means that you have an opportunity for contamination. Typically, when it's threaded, that means that there's plumber's tape and the chance for just grime and to just develop in there and build. Our unit is the one that's in the middle here. Our old units to the side, and you can see that it's a lower stack height. That doesn't seem like it's a big deal until you're spending your day sitting behind a laminar flow hood with that sneeze guard, and now you're having to try to get your arms underneath the sneeze guard and up and over to place the plates, the funnels on. So with that becomes more of a repetitive stress injury. You get someone who's doing 100 tests a day. They're constantly loading the funnels on, taking them off. So they're having to get their hands up and over. So we created one that has a really low stack height, which is fantastic. Customers absolutely love it. And you can see how clean the lines look, right? Something that's different from all of the competition out there is that you don't need any tools to clean ours and take it apart. I can take that unit completely apart the way you see on the bottom here on the left without any tools. Everything's just a quick disconnect, so you can pop them in and out. You can even change the O-rings with just the help of a pair of forceps, which every lab has. So no longer do you have to get the guy from the maintenance to come up, take it all apart, and then put it back together again. You can do it yourself at the end of the day. And this is great to remove any chances of cross-contamination going forward in your samples. So we talk about the Easy Stream pump, and you'll see that a lot of pumps out there look like the blue ones on the left. And what happens is between the manifold or the glass filtering flask, there's another flask there which helps protect the pump. It's a water trap, because if that pump was to be exposed to water, it would fail, and then they wouldn't be able to use it. So we have created a very quiet, it's called the Easy Stream pump, and it's a diaphragm pump which allows the water to get pulled through the funnel and then disposed straight into the carboy. So not only is it cleaner and efficient, we've gotten rid of the glassware, which could break. So, and if you go into the labs and you look at the glassware that they use, you'll see that it doesn't really look all that clean. You wouldn't want to drink out of it. And the reason you don't want to is because it's probably contaminated. So if it looks contaminated, there's probably an opportunity that it's going to contaminate the sample. Now, if I have a positive, is it because of my environment or is it because of the product that I tested? By having a cleaner and simpler pump, you're helping to remove all those pressures away from the lab tech. It's a way of making it simple. Now, they're going to buy a pump and it'll last, 3-5 years. So if they just recently bought one of the blue pumps that you see here or something similar, they're not going to immediately jump on it. But it's the kind of thing where you want to revisit and say, hey, are you having any issues with your pumps at this time? Are you looking to replace them? And then, go back to the advantages of this. It's a very nice discussion. They're quite happy with it. So our filtration units, the Easy Fit, really nice and simple. We have the blue and the pink. The blue typically for the beverage industry and the pink typically for the pharma, because the pharma requires you that you transfer the membrane, whereas the blue you do not. There's no plug for it. What is nice, both of these units, whether pink or blue, you can see on the bottom right, there's a small little lip to it, which allows for the membrane to, once you remove the funnel, it allows you easy access to that membrane. A lot of the units that are out there, all of the competition, require you to kind of dig in and get that membrane out. Well, by doing that, sometimes they tear the membrane. If they tear the membrane, they're supposed to void that test and do it over again. You can just ask them, hey, have you ever had to, or have you ever torn that membrane while you're trying to get it out? If they say yes, then here's that pain point that you can talk to them about and say, this isn't an issue when you're using the Easy Fit because they've created it with a small lip so you have nice access to it. The other thing they've done is we created the membrane support in a way so that the membrane would have a slight bow to it. So that, as you can see in that picture one, when they are rolling that membrane down, it's easier to get it and you don't have to worry about possible air bubbles, which is really, really nice. And the Easy Fit come in the 100 and 250 mil samples individually or in a bulk packaging. And you can see that the plastic is nice and clear. And why is having it stackable nice? Well, when you have real estate inside a laminar flow hood, if you can stack it up, that's great because then it means that you're not having this mess where your hands are all the time. Now, I did talk about using the ampules. So you can see here, if they're not going to use the auger plate, what they would do is they would take the ampule, squeeze it and put it onto the auger, onto the membrane, which then gets soaked up into the pad underneath. If you remember back here, the blue one has that membrane support. So that membrane support now is soaking up all of that media. And then they remove the funnel and take the lid from the unit, put it down, put the plug onto the bottom of the unit, and they have their Petri dish right away. So there's no membrane transfer here at all, but they have to still do some manipulations, right? Which is really quite nice. And then as we go upwards, we now have what's called the Milliflex Oasis system. And this is a fully integrated unit where it has its own pump heads, a decontamination cycle. And what's nice is that the membranes are attached to the base of the funnel. And as you see from the sequence on the left, there's my media plate. I can bring the membrane onto it, the whole funnel, transfer it over. And as you see in the middle one, there's that little circle. That's because the membrane is bowed because of pressure created. And then I can transfer that down onto the auger plate, not worrying about any air. And just by simply squeezing the funnel, I can remove it and then take the lid and put that down onto it. So I now have my auger plate. So that works out really, really well. Removes all of the chances of contamination and things like that. Now, I did briefly talk about the bubbles and why that's a problem. Well, here we go. Here's an example of what the bubbles can look like with a product. So it looks like a donut, and that's kind of neat. But the problem is that there are also organisms right in the dead center of this. But because there are bubbles, the organisms are not growing. And imagine where in this particular case, it's, TNTC, it's too numerous to count. We have loads of bacteria just growing here. But our customers are going to be dealing with, onesies and 1, 3, maybe 5 colonies. Well, if you're dealing with one and it's stuck in the middle, you may never know that you had a growth or that you had a problem. So with that becomes a concern for our users. So everything that we've done and developed is to help ensure that the product is working the way it's supposed to, and prevents adverse results. So we've got the funnels, the manifold, the pump, the membrane dispensers, the Oasis, all of these together. And these things just help make sure that our products are the best out there. So when you're looking at the competition, or you go into a facility that has a competitive device, these are some of the talking points that you have. Now, at this point, I'm going to send it back to Heather and ask if she has any questions that came through, or if anybody had something that they wanted to ask.
Yeah, it looks like we have a couple questions in the chat. Sarah says, I'm seeing bubbles between the membrane and the media. Is there a bad seal?
So when you have, it's not necessarily a seal. So they're rolling the membrane onto the agar plate. So it could be that the method that they're rolling the membrane onto it is poor, or needs to be worked on. It could be that the membrane, the device itself, as you saw in that previous picture, when it was attached to the device, and they try and lay it down, doesn't have the technology to create that bow. So now you have a bubble into it. So it's not necessarily that it's not attached properly. It's just that it doesn't have the proper membrane configuration and physical characteristics. How do I test for residue left behind from plates? Okay, so now we're talking about environmental monitoring. So if you are looking at, you're talking about, you've cleaned the bench area and now you've laid the agar plate onto it. Is that what we're looking at? If I could just get a quick yes or something from the person BG, so that I know that we're talking about environmental monitoring. Okay. Well, so what you would do is you're definitely looking at making sure that the cleaning process is working correctly. You are putting the plates down to make sure that it is cleaning, but obviously we're worried about the residue. There are different options out there. Instead of using plates, you can use swabs. Now, there are swabs that have that are non-fibrous material, which allow you to swab the area. You saw those red, blue, and yellow containers at the front. There was also a small swab beside it. You could, in fact, swab that area and put it into those containers. We also have other what we call ICR swabs, allow you to do that. So that is an option for you, is to swab the area instead of using the media plates. And then that way you don't have to worry about what's left behind, because typically those are a sterile buffer that's there, and they just evaporate. My vacuum isn't as strong as it used to be, and would I know why? So there's a couple things that can happen here. We know that, well, vacuums over time will die out, but what does happen is that you buy a new vacuum and it doesn't really seem to address the situation. You still have poor vacuum. Well, that can happen because the O-rings that are in the manifold are drying up, and so they're not creating as nice a seal. And that's why our manifold has an advantage, because I can change out those seals in just a matter of minutes, instead of getting somebody to come in with a wrench and take it all apart and then have to retape it, etc. I can do that in a matter of minutes. So now I don't have a problem with worrying about whether or not the O-rings are old. And that's also something to worry about for if you ever have growth on the bottom of your membrane. If the seals on if the O-rings are not sealing correctly, when I'm turning off that vacuum or when I'm trying to close it and I remove the membrane, I create a little suction coming back, like a backflow. And that means that the environment that's within the inside of that manifold is now coming back upwards onto the base of that membrane. Well, if that manifold hasn't been cleaned properly, or they're not maintaining it the way they should, then they're going to see growth on the bottom of the membrane. Has anyone had difficulty removing the membrane from an individually sealed packaging? I'm not sure I understand. Are you saying that from the funnel themselves, trying to remove that membrane, or from the membrane itself, the individual? Like in this particular case, looking at this page, we see the boxes and the dispenser, but removing the membrane that way from the dispenser should not be difficult at all. Each one of those is individually sealed, but you can see that it's basically comes out at quite a distance, so it's easy to pull out. If somebody is having difficulty in removing it because the membrane, I'll use the term sticking out its tongue far enough, the membrane's not coming out far enough, then it might be that it was loaded just a little bit incorrectly, and we're not getting enough membrane out, because it should be, as you see here in that picture, quite easy for you to remove, and that 70% of that membrane is ready to be used. I'm just looking here. I don't see any other questions. Shall I go on to the next slide? Is that okay with you, Heather?
Sounds good.
Okay. And BG, did I answer your questions with regards to swabbing the surface area? Okay. And RF, did I answer? Yep. Okay. Thanks. Great. So let's go to some probing questions. I thought you might like these since you're getting this presentation. This might be when you walk into a facility, what can I talk to them about? How can I ask them a question to maybe find some opportunities? When was the last time the O-rings were changed out in the manifold? Right? Just a simple question. How often do you change these out? I personally have been in one where they've said, gee, I can't remember the last time it was changed. And then the next question is, well, does it feel like the vacuum isn't as strong as it used to be? And then that question is, the answer usually is followed by, yep. Have you ever had problems with contamination? If the answer is yep, then we're looking at O-rings. So they've likely had that manifold for a long time. They haven't changed out the O-rings. They may be looking for a new one. Talk to them about the EasyFit manifold and the benefits of it. I talked about this briefly about, does your pump need a water trap? And has anybody ever broken it? Usually when you ask that question, there's usually a couple eyes that dart around the lab looking for, Bob in the corner, who's now cowering because he's the one that broke the $1,000 glass trap. So that's always something to worry about and ask. And here we talk about the bubble and pore contact between the membrane and the media. I showed you that image of what it looks like. If the customer ever says, yeah, we're experiencing those problems with our current funnels, then you may want to talk to them about the EasyFit and talk about how it was designed so that would remove that problem from happening. Could your workflow benefit by removing the membrane transfer step? Yeah. We might have the liquid media for you and then have them go straight to the EasyFit blue funnels. Do you use contact plates to confirm cleaning effectiveness? Worried about the residue? Yep. We just addressed this with the swab test kits. So you've got that as an option. And yeah, we addressed this with removing the membrane. So these questions, as probing questions, are things that come up often. And these are the kind of things that you can go into the lab, feel comfortable in asking them, if they've had any problems. So with that, we're pretty much coming to the end. So I'd like to open it up if there are any other questions.
And while everyone's typing out their other questions, I'm going to go ahead and share my screen for just a moment. Okay. So I just wanted to let you guys know that there is a promotion giveaway if you take the survey that is in the kiosk. There's also literatures, web links, as well as videos. On here, you will also find, oh, not that button, the on-demand tab. This talk will be on demand within 24 hours, so you will see it in here as well as the other talks that we have done so far this year. So take some time, explore all around, register for some upcoming talks, and I'll hand it back and see if anyone has any questions. And feel free to come off mute if you're still typing.
Yeah.
But I'm not seeing anything else. Last chance. All right, not seeing anything. All right,
Okay.
thank you all so much for joining us today. And I hope you all have a great rest of your day.
Thank you so much. And reach out to me if you have any questions at any time. I'd be glad to help.
Thanks, Michelle. Anytime.
Thanks, Michelle. Appreciate it.
Thank you.